Welcome. Good morning. Happy Minibar. Happy Minibar 20. Give a hand for Minibar. Cool vibe this morning. It's about 9:41. There's a couple folks rolling in, so I'll just fill a minute, but make sure everyone's in here, and then we'll get started. I just want to say I love Minibar. This is my third Minibar. Second time speaking on this stage, which is kind of cool. And what I love about Minibar is like they just give me a microphone and they let me talk about anything. You can talk about anything here. So I mean, man, those just give you a platform for whatever you want. But I love that because I just get to come here and talk about like whatever hobby or interest is scratching my brain that year. So you caught me on a mesh year this year. So that's what's going on here. Cool. Well, we'll kick things off. Thanks for coming to my talk. If you're here for decentralized mesh networks, you're in the right place. Just a disclaimer. So this is going to be about Meshtastic. If you are intimately familiar with what that is already, you're not going to get anything out of this talk. And I wouldn't be offended if you go and like leave the room and go to a different talk. This is really going to be like the 101. So if you know what that means and you're already into that, you're not going to learn anything from this. Otherwise, you're in the right place. So without further ado, let's get started and talk about like what this is and also what this isn't. We've got kind of a lot to go through. I'll hit a few different topics here and hopefully give you like the 101 on decentralized mesh networks from my perspective. So speaking of my perspective, I'm just going to give you an intro to me and some of my credentials. I'm Chris Wadicka. I'm a UX UI product designer at Livefront, and I work on mobile apps and websites. And I wanted to lead with my credentials and who I am because I'm telling you that I'm a UX designer. I'm kind of a product platform guy. And the space that we're going to go into right now is it's a really interesting space, but it's also like not exactly my space. Like I'm maybe not the most credentialed person to even be talking about this. I'm just really interested in it. So where we're going is a space that is, it's for like radio enthusiasts sometimes, and it's for like hardware people. But I'm more of a software guy than a hardware guy at the end of the day. My experience is in UX and in digital products and software. That's what I kind of live and breathe. And so my perspective on all of this stuff comes from more of a software and experience perspective. But that said, like I'm a serial tinkerer, I'm a hobbyist, I'm like into new shit every year. You can ask my girlfriend, and she always listens to whatever I have to say about whatever I'm into that year. So I love checking out all this new stuff like fringe technologies and things like that. So I have like really a permanent curiosity for like the new things that are coming out and like trying to think of systems in a different way. And that's really what led me to this mesh space. And the last thing I'll say about it is like I've got a little bit of that like stick it to the manness. I wouldn't necessarily say I have problems with authority, but like there's like stick it to the manness in what we're gonna talk about today. So you should know that about me because I have that in me and I always will. Cool. So what does decentralized mesh communication network mean? And it's a lot of words, and I just want to level set so that we're clear about what this is. Decentralized, we're not talking blockchain. Blockchain was like 3 years ago. If you're still doing blockchain, yeah, I'm sorry. Mesh, so we're going to talk about like lots of pieces talking to each other and kind of like dynamically. And then communication network. So for today, we're going to be talking about something that is purely for like text-based digital communication. So, you have all sorts of different mesh networks, or maybe you have like a Wi-Fi mesh network in your house. This is going to be like really just simple text-based stuff. So that I think frames like what we're going to talk about technically today in a pretty good way. So, why would someone care about this, and what types of figures would be interested in a decentralized mesh communication network? So there's a few different use cases for why people get into a space like this. The first one that I'll call out is like maybe if you're into remote adventuring or like backcountry stuff, or like you're hitting a ski slope like out in Montana somewhere that doesn't have like cell service. People use communication mesh networks like this for talking with their friends in places that just doesn't have infrastructure or like cell coverage. Maybe think like backcountry Utah camping or something like that. So that's a space for people that are interested in this kind of stuff. Another space that this really touches on is like privacy and surveillance. So like obviously we have big tech companies and like governments like sucking up our data, and we have data brokers, and we have people that are like using our communications in maybe nefarious ways. And so you have definitely a good portion of folks who are interested in this from a privacy perspective. How can we create communication infrastructure that's different from what we have now and is maybe regulated in different ways or not regulated at all? And then kind of the full other side of the pendulum is like the preppers. If you're in this talk, you're a certified prepper after you listen to all this stuff. So we're talking about people who like are daydreaming about like infrastructure collapse and what would happen like when everything goes down, like a doomsday. And so that's also like part of this space. And it's kind of an interesting thought experiment to see like what would happen if you couldn't text or FaceTime anyone. How would you talk to people? So that's kind of the spaces that this inhibits. And I think there's something for everyone in things like this. Oh, and zombies. So I mentioned this at the top, and it's okay if you're not familiar with this, but I'm going to be focusing on a platform today called Meshtastic. It's a little bit of a silly name, but this is an open source platform that is created by a team of people and like a whole lot of contributors. And I'm going to go a little bit over like what Meshtastic is, but then we're really going to talk about like how it works and what it is and like what this technology enables, because it's really interesting. So Meshtastic is an open source platform. They have a number of different softwares, like they have the actual firmware that runs on radio devices. And then they also have native Android and iOS apps. They also have like a web interface where you can do meshy things on your computer. So that's like Meshtastic at a huge flyover, but we're going to get into it more. So Meshtastic is a platform that runs on small radio devices, and it works over a protocol called LoRa. And LoRa stands for long range. It's a pretty simple little acronym. And what makes LoRa really interesting and really well suited for a project like Meshtastic is that given the name, it's long range. It facilitates long range radio operations at a pretty small bandwidth. A good connection might get like 1 to 2 kilobits per second. So it's not really suitable for any like high data transfer video or like internet-y kind of things. Then another thing about LoRa is that it's really easy to run on low power, small devices and like cheap boards. And you can run it on a lot of different things if you have like a LoRa module connected to a small radio device. In this sense, and in the context of Meshtastic, what we're going to talk about, LoRa acts as the wireless communication layer. So as we're talking more and more about like this decentralized mesh communication network, we're talking about that this is the infrastructure. The infrastructure is this low power, long distance wireless protocol that this whole mesh network is built on. Some other interesting things about LoRa that make it well suited for this are that it operates on some unlicensed bands. And this depends on what country you're in for what band it is. In America, it's like 900 megahertz to 928 megahertz. But the point about this being unlicensed is that to use it, you don't need any certifications or licenses like you might need for a ham radio or GMRS radio. So it makes it's a really low barrier to entry for people who want to check this out and use it. And then another thing you might be wondering about is distance. So like, how, like, if we're going to build a mesh network where people can talk to each other over a region, what is the distance that this can work over? So in like a dense city where you have like houses, buildings, trees, obstructions, you can easily see like 1 to 2 blocks of transmission. I've done it plenty of times in my testing. But where LoRa really shines is like if you have a clear line of sight between 2 radios, you can get a transmission of like 10 to 100 miles, which is really far. So if you think about like connecting people with like literally little handheld pocket radios, it's pretty fantastic. The highest ground transmission that they've recorded using Meshtastic is over 200 miles. So it's pretty far. Okay, so this is a really brief explainer of how Meshtastic actually works with these LoRa radios that I've been kind of alluding to. Pretty much like to build out a mesh network, you would have all of these little devices that you'd call nodes. So it could be any type of hardware that's running a LoRa radio and the Meshtastic firmware on it. And these devices will talk to each other when you're doing communications. What you'll commonly see is Meshtastic nodes that have Bluetooth, and you can connect your phone to them. And then the communication is kind of facilitated using the phone through the node. And we also have nodes that you don't need a phone and they have like a little keyboard. So this is a really simple explainer. I'm going to give you a little bit better of an explainer of how this stuff actually works and how the mesh networks are made and how people can use them. So imagine you have a place like this, and you and your friend are across town and you want to like talk to each other on this like back channel mesh communication network. How would you do that? So in this instance, you would envision that around town, there are all of these Meshtastic nodes. And like these are owned and operated by just folks around town who are interested in this thing. And if you want to send your message to your friend, when you send out a message from your node is going to start talking to all the other ones that it can hear in a region. And that's going to allow your message to pass through whatever nodes it takes to get to your friend. So that kind of leads me directly into routing and like how does the one message know how to get to the person that it needs to get to in a mesh. They could be like right next to you, like maybe a couple houses away, but they could also be like between Northeast Minneapolis and Bloomington. So how does the message know where to go? So Meshtastic has a unique routing scheme called managed flooding, which is, it's interesting. So the way that managed flooding works is there's no route that's established beforehand. Like the message doesn't know where to go when you hit send. The message has a way of finding its way through the mesh using this managed flooding routing. So what happens when you send a message from your node is that your node shouts it out into the radio void on this unlicensed radio network. And then whatever nodes nearby that can hear your message, they're going to receive that message and then they're going to shout it out from wherever they're at. And that just keeps happening. And this message kind of floats around until it finds the person that it knows it's intended for, with your message information and message headers. So this isn't like, it's not like traditional like TCP or IP where you have like a direct address and there's like a direct route and it knows exactly where to go. The message actually kind of like meanders a little bit to find where it needs to go. And so that makes this really good for dynamic hardware systems or dynamic infrastructure systems where like nodes might be moving or changing at any time. So in this sense, it's basically like the fastest path, even if there are multiple paths for a message to get from one place to another. This is like wildly generalized and simplified, but I think like visualizing it as like the fastest path is probably the most straightforward way to represent this. Another thing to know is that when a message goes from one node to another node, it's called a hop. And so Meshtastic in their firmware has a 7-hop limit built in. If they didn't have a hop limit, a message could end up in a series of nodes and just like start spinning or kind of like echo around like this, and it would never end. So they have a hard limit built in for hops. And then the last thing that I'll say about this that's maybe obvious, but we're going to talk about it more, is that there's no central authority to how a mesh infrastructure is created. There's no registry. This goes back to like routes. Like nobody is telling you where something lives or where it has to go. There's a local node database on each node that just keeps a record of nodes that it hears nearby that it knows are there. And it just, it keeps that in its local node database, but nothing central, no authority. So that's really the decentralized part of all of this. So I'm alluding to a little bit of this about how the mesh works, but what's really magic about how Meshtastic works and how these radio nodes interface together is that even if nodes in the mesh change, maybe one goes offline or becomes unavailable for some reason, there can still be multiple different paths for one node to reach another node within a mesh. So in this sense, it makes it really resilient to change for the nodes that might be in a mesh. There could also just be instances where like the wind is blowing differently one day and like one node that wasn't able to talk to each other before is like now able to talk to it for a little bit. So the mesh is like really truly dynamic in that way, and it's an interesting theory that Meshtastic has set up. So again, this is like the 50,000-foot flyover of like what Meshtastic is and how it works and how messages are routed. You probably came to this talk wondering like how this stuff is going to work and like what it is. And now you're probably wondering like, that's awesome. Can we actually like build something out like this in Minneapolis? I'm interested in this. Well, I'm here to tell you that it's already here. This already exists in Minneapolis. And it's something that a lot of dedicated folks have been working on. And it's a really cool community effort. So in the Twin Cities, there are like 700 plus active nodes across the region. Obviously, we're looking at like a space from like the central metro out to some like second or third ring suburbs here. But most of that node density is mostly centralized around the main MSP area. One thing I'll just note about this map is like, we're looking at a distance of like over 120 miles here where people can link nodes together and talk to each other. I personally have sent messages from like Paynesville, Minnesota to South Minneapolis, which is a transmission of like 100 miles of like hopping through different nodes to talk to somebody, which I think is really incredible. So this map and this visualization are just showing a little bit more zoomed in area of the MSP mesh that exists in the metro. And then what that starts to look like at more of a local level, like when you're looking at like uptown, downtown, northeast here, you can see where there are different little like clusters of nodes. People have been interested in this. People buy nodes and they put them up, and then it starts to connect everyone around. So this is my time to plug MSP Mesh, which is the community that helps facilitate all of this stuff. It's a great community. I'm part of it. They have lots of local resources to tell you like how Meshtastic works, how it works in Minnesota, how to set up radio settings if you were to get your first radio. And they also run a community Discord where people answer questions really thoughtfully and help teach people about how all of this stuff works. So this is where the community lives, and there's lots going on there, and it's a really cool effort. I want to zoom back out because my whole talk isn't just about MSP Mesh, but I want to talk about some other aspects of Meshtastic. I want to point out that most states have mesh communities as well. So this is like a grassroots thing in the Twin Cities, but there's also a ton of other people that are doing this across the country and also across the world. It's a total worldwide phenomenon that people are checking this thing out. So I think Meshtastic is really cool. It's like an idea that really tickled my brain when I learned about it and like thinking about people-owned infrastructure. And the possibilities to me seemed kind of limitless. So I think there are a lot of possibilities with Meshtastic, but I do also want to bring some realities that I've learned about the platform as I've started using it over the last 6 months. So some like really hard and fast truths about it are that like when you get your first radio and you want to like interact with this mesh network that exists around us, one thing to know is that it's really easy to receive messages and it's kind of hard to transmit messages at first. The way that these radios work make it easy to listen for things that are coming in. But when you get your first radio, finding like that optimal transmit spot can be a little bit harder. It might be like propping it up in a window in the second story of your house, or like going to the park on the hill and like holding it in the air to see if anyone nearby can hear you. And it's really all about like finding nearby nodes that you can connect to that people already have established in your community. One thing that you'll hear in the Meshtastic community is that height is might. And this really means that placing nodes as high as possible gives it the best chance for that line of sight that I mentioned, to allow nodes to connect to each other. A common misconception is that you can get a node and just like make it be really high powered, and then that will make it reach to other nodes more easily. But the truth is that height and line of sight are really the best predictors of having a good connection to other nodes. Another thing I wanted to point out is that when you start using Meshtastic, there's an unencrypted default chat room. So like in MSP, there's like hundreds of people in this like random chat room, and like it's the default that gets loaded on the app. And there's like not a lot of substantial conversations that happen in there. It's mostly people sending like testing, good morning. It's like people just making sure that their messages are reaching the broader mesh as they're like talking to people. So it really is like the default chat room is kind of like a hobby space and kind of just like people testing stuff. But there's certainly some interesting conversations that happen there sometimes. Another thing I wanted to call out that we're not going to get too much into in this talk is that in Meshtastic, there are different device roles that modify the broadcast functions of your node. And so these different device roles will dictate how messages are maybe rebroadcasted from other nodes. I'm not going to list them all here, but the ones that you would commonly use on a regular node that you buy is like client or client mute. So if you're on the client role, it means that if your node hears messages, it will retransmit them. If you're on client mute, it means it will not retransmit them. And then the last thing I want to call out about Meshtastic is that it's really cool. It's a neat technology and it's interesting. But I want to call out that it's not emergency comms. In my opinion, it's not reliable enough to be used for something that's like a critical infrastructure. And it's not something I see like police departments or like cities full on adopting. I think there's still a lot of kind of flakiness with it that they have to contend with as a platform. So next we're going to move into hardware a little bit. I'm going to give you just a flyover of like, if you were interested in this, where would you go from a hardware perspective? How do you actually get started in this mesh network that we have? So there are a lot of existing brands that make pre-made hardware where you can interact with this stuff. I mentioned it a few minutes ago, but there are some nodes where you can connect with your phone to Bluetooth to interact with the node via a mobile app. There's also pre-made devices like LilyGo TDEC devices that have keyboards and their own OS built into it where you can message people. And you have a range of like things that run on batteries that you can put in your pocket or things that use solar panels that you can mount places. Also, a lot of people in this space like to build their own nodes. So like bust out your soldering iron and like order the parts yourself. I mentioned at the top that I'm not a hardware guy and I don't care about doing stuff like that. But that's a huge part of this community as well. So if you're into like more hardware and tinkering and building stuff, this is definitely the right space for you. I want to call out the two manufacturers on the bottom on the left. YetiWorks is a local manufacturer who makes pre-built nodes and sells them online. So it's a local person who does that, and those are high quality. And then Peak Mesh is also a seller on Etsy who designs and builds their own nodes and sends them out on Etsy. And I bought a couple of those, and they are extremely high quality and really cool. By way of hardware, I also want to take a minute to talk about node types, because when we're talking about these nodes, they kind of come in a lot of different form factors and they have different use cases. So a pocket node would be something that's like battery operated. You'd carry it on your person to just like connect to the mesh wherever you are. I have one right here and it's kind of pictured there, but it's like literally the size of like a little wallet or something like that. And like the radio in this is good enough to connect over those like 1 or 2 blocks or like even farther, like I mentioned earlier. Another thing that people might use is a base node. So this is something that you might hang like really high up in a tree or mount on top of your house. I have one strung up in our tree in our backyard, God willing. And so these base nodes tend to have solar panels, like I mentioned. They'll have enough batteries in them usually to like last a month where they can keep running even if it doesn't get any sun. So it's really sustainable to mount these in places where they're not very obstructed or obtrusive. So these are the ones that would act as like more of like a home base for your mesh. Like if you were going to put one of these up at your house, and then you would connect to that to be able to get to like maybe your neighbors around you. And then another one is car nodes. Sometimes people will like magnet mount these on the top of their cars to act as like more of a mobile base station for themselves. It's pretty common in the mesh community for people to have like multiple nodes. You might have your little pocket one, like I mentioned, and you might have one like strung up in your tree or mounted on your house. But you don't have to do it. You can kind of interact however you want. And then the last thing I'll mention for node types is a router node. And this is kind of a specialized device role. I talked about device roles a second ago. And this is something that's really carefully and deliberately placed in a mesh environment or in a mesh region. And this is where a community like MSP Mesh really shines. So community members can find the most optimal places for these router nodes. And these tend to be the highest locations in a region. So think like on top of a radio tower, maybe a silo that we might find in Minnesota, on top of a hill or a mountain. And these router nodes serve as a backbone of like a local mesh infrastructure to do the main routing between different parts of a region where people are connecting to. So that's kind of a lot about hardware. I threw like a bunch of brands at you. If this is something you're like listening to and you're pretty interested in and want to check it out as soon as possible and get in like the lowest barrier to entry, this is what I would buy if I were you. It's the one that I just flashed that was in my pocket. It's called a SenseCap T1000E card tracker. It's got Bluetooth built in, so you would just use your phone to connect to it, to use it. It's got GPS built in, which is optional as well. Works with iOS and Android. Comes pre-flashed with Meshtastic firmware, and it's only $40. I've got retailers like on the very last slide, but you can get it on like Amazon and a couple other mesh retailers. So lots about the hardware here. This is your getting started point if you're really interested in it. Meshtastic is a cool platform. I think there are some interesting possibilities. Next, I want to talk to you about my criticisms because I have criticisms of the platform as well. So the first thing I'll call out, and like I'm a UI guy and like it's literally my job, but the mobile UI is kind of janky, and I would say it's like a little confusing, especially for new users. There's lots of like technical conventions in the mobile app, and you can tell that there's like lots of things tacked onto the mobile app that maybe don't serve every use case or like new users. The next thing I called out that I touched on a second ago is that message send and receive can be somewhat unreliable, especially in a larger regional mesh like the one that we have here. It's not uncommon to like send out a message and maybe it doesn't reach the person you're trying to talk to or like the broader mesh. And that's all about finding your optimal, sending location and where your node placement is and stuff like that. But even so, like these are just like radio waves flying through the air on low power devices, and it's not completely reliable in terms of message sending. So I'm kind of curbing expectations here. The next thing I want to call out, and this is like the one that really does it for me, is that the network actually degrades as it scales up. So that managed flooding scheme that I talked to you about when we looked at how it works, that actually makes this not suitable for scaling it up larger. So what happens when you start adding more and more nodes to a mesh is that those nodes are broadcasting like telemetry periodically, like the name, the battery level, and like some other types of telemetry. And when you start adding more nodes, it makes the mesh environment louder, and it gets a little more convoluted, and then like the message reliability starts to go down. And there are other projects that deal with this, but Meshtastic does not scale very well when you start to get maybe thousands of nodes in a mesh. And I'm also saying this because it calls out that it's not suitable for like a countrywide mesh necessarily. It works better for small regional places. Another thing on like message encryption is that you have the option to send encrypted private messages to people in various forms. I just want to call out that messages that are sent encrypted are susceptible to harvest now, decrypt later attacks. This basically means like someone could run a honeypot where they are capturing like message content coming through a mesh. They could run it for like a year and they wouldn't be able to read any of those messages if they're encrypted. But if they were to obtain like a message key or an encryption key for what those encrypted messages were, they could run that key across all of the previous messages and decrypt all of them. So that's to say that there is not perfect forward secrecy built into Meshtastic at this time. Again, this is my UX hat coming on, but overall, I feel like the product and the feature positioning of Meshtastic is like, it's trying to do a lot of things at once. I don't think it's well suited for new users and for wide adoption. I think they're really trying to cater to the backcountry folks, and they haven't totally built it well for like large infrastructure. And I think there's a little bit of an identity crisis there. I can give Meshtastic a pass on this because like this is like a new fringe technology and they're like, it's in really early stages of what this stuff is. But I feel like it's worth calling out if you're someone who's never heard of this before and you're getting into it for the first time. And then the last thing that I'll cap this off on, which kind of encapsulates all of my criticisms, are that I think Meshtastic is a really cool tech hobby. And there's, like I said, there's something for everyone. But I look at it as more of a toy or a proof of concept than a robust platform. And it's not without its issues. So it's just, it's how I want to frame what this is so that you don't get too excited about what it might be able to do, knowing some of those limitations. So that's like kind of the 101 on Meshtastic. I want to spend the last couple minutes talking about a small project that I worked on this winter in light of recent events that I thought was interesting. So I made a small app called Meshtastic Signal Bridge. And what this is it's a software bridge to allow people on Meshtastic and Signal to communicate with each other in the event that there are people who have mesh nodes that are in situations where they don't have cell service and want to talk with other people who are in a Signal group. This winter I was outside doing a lot of this, and there were situations where I was in where I felt like I could. Thank you. I was in situations where I felt like this is something that I could use. Maybe a case in point, like I showed up to an event where there was like 20,000 people and like there was no cell service. And like that makes a lot of sense because like cell networks were overwhelmed. And it got me thinking like, how would I communicate with people in a time like that if I really needed to and I wasn't able to? So I made this piece of software called Meshtastic Signal Bridge to do just that. My thinking is like not all of your friends should have to have these Meshtastic nodes to be able to talk to you, even though it'd be nice if they did. And people were doing a lot of communicating via Signal, of course. So it's a pretty small app. It's like a 600-line Python app, and it's really just like relaying messages between the two platforms. And I'm going to demonstrate how it works and also a couple of the caveats of what this app is. So we'll go back to this mesh representation that I brought up earlier. And how this program works is like if I was going to run this, I would run it at my house as a single user, and I would run it for like a small group of friends or like trusted people that I know. And I would run it on a Linux host that is like at my house. And that host would have its own dedicated Meshtastic node connected to it. It would also be authenticated to my Signal account. And then what the program does is it bridges a Signal group chat with a private Meshtastic group chat. And on either side of those, you can have any users. So you can have your Signal users in this group, and then maybe a subset of those Signal users have mesh nodes, or you just have people who are mesh users in this mesh group. And so you'd put an encryption key on that Meshtastic group, and then you'd have your private Signal group. And what happens is, I might be over here on this side of town, not by my house, doing things like this. And if I want to talk to my friends who are on Signal, I would send my messages through the Meshtastic private group. And then those messages would find their way back to my host at home. It would do the translating, and then it would relay the messages back and forth and use the mesh as kind of the infrastructure to talk between Meshtastic users and Signal users. It also supports like having multiple people on the mesh as well. So maybe you're with a couple friends who also have mesh devices, or maybe there are other people not in your physical vicinity who are also trying to utilize the same communication groups. So this is also like a little bit of a proof of concept of something that I wanted to put together, like I mentioned, in light of recent times. And it's something that I think is an interesting piece of software. So just to cap that off, I made Meshtastic Signal Bridge to facilitate communication to a broader signal group via Meshtastic when cellular and wireless networks are unreliable or disrupted. And the thing I want to like really underline is that this software really acts as a trusted gateway. So this is something you would use for yourself and maybe a couple other people. This is not a service that you would run for like a broad group of people. Anyone who wanted to use this would kind of have to run their own instance under those very specific conditions that I mentioned. And then the other thing that I'll mention about this being a trusted gateway is that messages that come through the bridge are susceptible to being inspected by whoever sets up the bridge. So the way the program works is like it has to see all of the Meshtastic messages that come in and all of the Signal messages. So that's just to really underscore that like you would only use this with someone that you like personally know, personally trust, and you're using it for like a small group of people to communicate. So feel free to check that out. I think it's an interesting project. We're gonna get things wrapped up here, and then we'll have some time to chat about this stuff as well. Here is a culmination of some of the links and ideas that I brought forward during the talk. That SenseCap little node card that I talked about is second to the last bullet. So if you wanted to buy that, there's a few different distributors, including but not limited to Amazon, if you want to buy it. And then I also have some additional mesh reading for ideas that we didn't talk about in this talk, if you're like interested in this stuff and want to see where the rabbit hole goes. There's a platform called Reticulum that I think is extremely interesting, that I think solves a lot of the problems that I talked about. And there's a guy on YouTube who's doing some really, really interesting things with that I like. So just to recap, I'm Chris Wadicka. I work at Livefront. I'm a product guy, not a hardware guy. If you want to download a copy of the PDF with all the information, you can scan that here. Thanks for letting me talk to you about meshes and decentralized stuff and like nerd out for a little bit. And I would love to just take a couple minutes and chat if anyone has like questions or if you want to say stuff about stuff. Right here, yeah.
One thing about the map, great presentation, by the way.
Thanks.
And actually, it's funny, before the chat, I was talking to Matt sitting here next to me, and like your criticism bullet point, I literally went through it with him. I have the exact same thing. I've never even seen your presentation. It's very common. The map, the thing that you want to think about is like you don't have to broadcast location. The map is either the node sending out a GPS location or somebody placing a pin on the map at MSQX. So, for example, the 700 plus nodes that we saw in that map is not a full representation of the nodes in the infrastructure. There could be thousands of invisible nodes that sit in the infrastructure. So just like think about that when you're threat modeling for it. The other thing is the main primary chat that will come on a Meshtastic device, like when he talks about unreliable chat, is also that it's not a complete chat. So like you will open up your Meshtastic map or your app on your phone, you'll see people saying test, test, test. You might only be seeing a tenth of the entire chat history. You won't even know it. So you'll send a message, and your message will end up on maybe 5 devices, but you don't know which 5 devices they are and who in the mesh has seen your message. So it's not like your mental model of like a Slack app where the entire history, entire context of your chat is happening, you don't really understand the messages you receive as being complete. You only get what you get, if that makes sense. Like that's kind of one of the criticisms is like you really don't know when you open up, even on your own private chats, whether or not you're seeing the full context of the messages.
Yeah.
It's difficult, but if you want to see it, talk about it.
Yeah. Yeah. Thanks for sharing those thoughts. All valid. Makes a lot of sense. Tyler.
So you said that you were able to send a message like 120 miles, right?
Yeah.
What's latency look like in that kind of a scenario?
Yeah, that's a good question. Latency is kind of the question here. Pretty damn fast. We're talking like seconds, if anything. But again, it depends on how many node hops you have and how far it has to go. Yeah. Yeah, right here. That's an interesting question. I personally don't know. I'll say from what I've learned about Meshtastic and kind of these radio networks, I'd say it's possible. I think someone could do it if they wanted to. Yeah. Way up in the corner in the back.
What's the status of any legal extension or lack of
Oh, yeah. Yeah. Yeah, that's a good question. Personally, I don't know, but I think it's an awesome question. Do you have any insight?
You can get a bad, like a potentially bad habit. My radio won't rebroadcast it. That's kind of a selfish way to look at it. You're not a phone company. You're not treated as a common carrier or some rando with $40.
Yeah. Yeah, that's an interesting question. You should look into it and let me know. Thanks. I need to know. Right here.
On the more technical side of things, you mentioned that with the way managed flooding works, that you just broadcast out to each node individually. It sounds like the nodes do have unique identifiers, though. Is that correct?
Yeah, they do.
UID or something?
Yeah.
Well, over in TCP/IP link, things have like a backtrace of the not nodes, but IP addresses they pass through as routers on their way to on their way to their destination. Would that be possible to implement to just say like, hey, if my name's in here, don't retransmit?
I assume it would be possible. I think that makes a lot of sense. I think. Oh, sorry. Can you say that again? Oh, yeah. It could probably be possible. One thing I'll say about Meshtastic is they try to keep the packets really low because it is such a low bandwidth platform. There are other platforms, and I dropped them on one of the last slides that start to deal with stuff like that. But to my knowledge, I don't think Meshtastic deals with that very well, just in terms of routing. Yeah. Yeah, I'm not gonna get the exact number, but I think the message limit is like 200 bytes. And we're talking like text, 200 bytes. It's like 200, 240 or something like that. No. But at the base firmware, no. I don't think so. Yeah, Alec. Yeah. So short answer, you would have to set up different nodes. How a lot of this hardware works is that like Mesh Core is kind of like the other analogous platform to this. You could flash Mesh Core firmware to a lot of similar Meshtastic devices. You just can't run them at the same time on the same hardware. Yeah. Yeah, Chris.
Yeah, in terms of messages dropping, do you get any sort of indication that you miss, or that like you might say, yeah, this is my last
There's a little bit of feedback. Your message will be marked in the app if it got delivered to a nearby node directly, but it's a complicated answer. No, generally, but there's also this idea of DMs in Meshtastic, and that does have a little bit more verifiability. It just requires like sending it out, and then like the success response also has to make it back, and it can be a little flaky. So, yeah, yeah, good question though. Cool. Right here.
You talk about scale and degradation. Is there any way it would be viable for like that situation when you have thousands of people gathered with enough nodes, or just going to break down?
Yeah, that's a great question. With Meshtastic, my understanding is the scaling isn't great. I think Reticulum is something that solves this really well, which is a totally different platform. There are some different technical implementations there. Yeah, maybe one more.
Does it go the breadth that the original package?
That's a good question. The question is, does the success response take the same route that the message took to get there? I don't know for a fact. My inclination would be it just takes whatever route it needs back. I don't know if either of you guys know the answer to that, but no, I don't know what the answer to that is. Okay, we'll do one more. Then it'll be good.
Is it possible to encapsulate traffic or actual TCP/IP connection? Let's say we're doing something over long distances, just going along the pipe.
Yeah, it is possible to connect like over TCP/IP. You can connect like with MQTT. There's a little like puricism in the Meshtastic community of like keeping it radio only, but yeah, you can link like over the internet to connect nodes. Cool. Well, thanks for coming to learn about meshes with me. Thank you. Thank you. If you have any other questions or want to chat, find me later, and have a good rest of your mini bar today. See ya.